Stat A. (10.2.1) one proportion hypothesis testing, or test, I'm just going to go with test, day 1. Okay. So, we're conducting a hypothesis test, and more importantly, we are doing proportions. Proportion of one variable, P. So our parameter is P, right? The proportion of ... Okay, so we have some parameters, something that we're looking at, and it's always going to be proportions. We're not going to study means in this course. We're not going to study other variables. We're only studying proportions for one variable. You can also compare two proportions. How does this proportion from this population compare to this proportion of the other population? We're not going to get into that type of material. In an AP course, in a college course, you will go further in going and doing hypothesis testing there. We talked about there that, you know, and yes, this kind of counts as step 1 as well. And step 1 is to identify the hypothesis, all right? Review, of course, what we did yesterday and the day before. My hypothesis is HO, the null hypothesis, P equals blank. And my alternative hypothesis, P something blank. And that blank is, of course, P0 that goes inside here, which is the hypothesized mean for in here. This can be a less than symbol, a greater than symbol, or a not equal to symbol. That's step 1. We did a homework on it. We did more practice yesterday. Those of you that were in the AP exam got that homework excused. If you wish to do it for extra credit, you may do so. Then we move on to step 2. Step 2 is the assumptions check. This is also what we covered yesterday. This is in the assumptions where we do SIN. We want to make sure that the sample is random. We want to make sure that the sample has independence, or that N is less than 10% of the population. And we talked about yesterday that in doing this normality check, the success and failures condition, we are actually checking N times P0, all right? Not the sample, not what we get in our sample, but P0. That must be at least 10, and N times 1 minus P0 must be at least 10. Now, in our do now, we already did that. Step 3. Step 3 is the z-score and p-value. All right, I'm going to tell you what those are in a little right now. So first off, the z-score is equal to p hat minus po over the standard deviation of p hat. Okay? And the p-value is equal to a normal CDF ... calculation. And I know that's not a lot, or of course we could also use a, like we did in the do now, a z-table. A p-value is the probability, so a p-value is a probability of getting our sample results if the null hypothesis is true. In other words, if P is in fact P0, what's the probability I did this? And we did this during the do now earlier. However, I'm going to show you another way of doing it. And here's a very important thing. The graphing, the TI-84 will find Z and PV for you. You just need to know how. And let me now show you how, because if you cannot do what I'm about to show you right now in the graphing calculator, you will fail this exam. Because it relies on you using the graphing calculator. Now, you could use the methods we just did, which is review. You could use the method we did in the do now and finding the z-score by hand, using the z formula, and finding the p-value by using normal CDF and determine if it's a one-tailed or two-tailed. If it's two-tailed, you multiply it by 2. I'm not teaching you that way, though. I want you to kind of get an idea of it, but how it's so easy. So the way we do this is you're going to hit second vars. So, oh, no, sorry. Nope. You're going to hit stat, and then you're going to select test. Stat, test. So please place that. If you're not following along with these buttons, you're screwed on this exam. Stat, you're going to go over the test, and then you're going to go down or up, however you want to do it. And or actually down. And you're going to select number 5. 1 prop Z test. Because that's what we're doing. Now, why the letter Z? What does 1 prop mean? What does 1 prop mean? 1 proportion. What is the Z referring to? Z-score, which means we're using a normal model. There's another one called T, and there's some other tests that don't use the letter Z because those tests don't use a normal model. They use different models and different distributions that we're not covering in this intro class. And the word test is used because we're conducting a H. We're doing a hypothesis test. Test stands for hypothesis test. All right. Now, when you do that, when you select that, now make sure you're selecting the correct one. It's going to ask you, what is P0? It's going to ask you, what is X? It's going to ask you, what is N? And then it's going to say prop, and it's going to give you 3 options. It's going to say not equal to P0, less than P0, greater than P0. And these are based on the alternative hypothesis. So however you wrote your alternative hypothesis is what you select there. Correct. Good. I agree. Calculator steps. Now, let's do the example that we did from our do now. In the do now, right, PO was 0.24, right? So, sorry, let me write it this way. In my do now, the null hypothesis was P equals 0.24, and the alternative hypothesis was P was less than 0.24. This is from the do now example that we did. We checked the assumptions, all good. We also found that the number of blue M&Ms, there were 6 blue M&Ms, and there was 54 M&Ms, which gave me a p hat of 0.111, right? X representing how many blue M&Ms we found, how many successes were there in the sample, and in the sample size. And we are literally going to write that information in here. So we're going to put my P0 inside here for my do now. I'm actually just going to go to the calculator on here. So stat test number 5. PO is 0.24. Yes? Null hypothesis. X is how many we observed? 6. Also, you can, so that N was 54, and the symbol was less than. Now, you could click draw, and it's actually going to draw the normal model with the shading. That's kind of cool, but we don't need that. Well, like if I do draw here, you can see that little itty bitty shading that's over there. You see it? Because that's what we did when we were doing normal CDF. But I don't want you to do that because the numbers are still underneath that we need. But I'm not a fan of this way, so don't do that. Just do calculate. So stat test 5, and it just goes straight to calculate. With the fancy ones, you have the option. So there's my z-score. What did we get in the do now? We got a z-score of 2.22. 2.22. 2.217, which is 2.22. Negative, sorry. And my z-score, 0.0132. This 0.0138, but it's about the same thing. No, and the p-hat is the sample proportion that we already found. That was 0.11. We don't need that information, but that's what we had gotten when we did that work. It is. That's why I'm trying to teach you this way. But it's simple if you appreciate what it is that we were doing. If I don't show you how we do it by hand and all that lead up, then all this looks to you and you go, these are just numbers. I have no clue what they mean. And so there, that P right there, that P is not the proportion, that P is the P value. That P represents the P value. So when I do that, and I would get, I might do now, I get that the z-score is negative 2.22, and my P value was 0.0132. Okay? And we did that by hand. So that's the third step. Step 3, complete. That's the major one right there. That if you don't know how to do those calculator steps and your features and your buttons and your calculator, then you can't go to step 4. There's another step. I told you, big lesson day today. All right. So now the question is, well, what do we do with that? Step 4. Make a decision. All right. Now, when we make a decision, there's 2 decisions that we can do. Decision 1 is we reject the null hypothesis. Option 2 is that we fail to reject the null hypothesis. Remember I told you guilty or not guilty? You either reject that they're innocent and you find them guilty, or you fail to reject the null hypothesis. You find them not guilty. You don't accept the null hypothesis. Now, how do we know which one we do? So, we reject the null hypothesis if the p-value, or PV, I'm going to write it as PV, is less than blank, we reject the null hypothesis. And the other one, yeah, so if the p-value, if PV is greater than blank, then we fail to reject the null hypothesis. Now, what probability, and I've told you this before, What is our default probability that we find it unusual for? And I've mentioned this percentage, this decimal. I said if it's less, and I've said this a couple of times throughout the year of the course, if the probability is less than blank, we will find it to be unusual. Does anybody recall what that? It's 5%. If we have less than a 5%, if the probability is less than 5%, that's when we consider in statistics. That's our default level. So the decimal is 0.05. I'm not going to get into it about why we would use other values. Okay, so alpha. This is called the alpha equals 0.05. This is it has a couple things: the alpha level. Which is also written as like 5%. This is our default. I'm not going to get into why we use it. I don't have time. I'm not going to get into why would you use it 1% or 10% level of significance. But 5% is what we use as our default. So if the p-value is less than 0.05, we found evidence that they're lying to us. In our do now, going back to our do now. And then, of course, and to finish step 2, so this is, this I would call step 4A. And step 4B would be to answer the question. Answer the question. Is there evidence that they're lying? Is there evidence that they're telling the truth? Remember, the question was that we believe that they are shortchanging the blue M&Ms. So there is blank evidence to suggest blank. And this blank right here, I'm going to put in brackets. And I hate using this word, but I'm going to say no. There is evidence or there is no evidence. Because no is very strong because there's some evidence. There's just not enough evidence. No is a very strong word because technically there is some evidence, but some people accept it. And for you guys, I don't want to go into the nuances of things. Either there is evidence or there's not evidence. So there is evidence if the probability, the p-value is less than 0.05. There's not evidence if it's greater than, because it's within the variability. All right. And to suggest, and this is just the dot right here is basically where you are just putting the alternative hypothesis in words. Basically, you're going to copy the question down. What are we trying to do? There is evidence that that the proportion of M&Ms that are blue is less than 24%. So that's what we're trying to find on this one. So going back to the do now. Going back to the do now. Remember, the z-score was negative 2.22, and the p-value was 1.32 or 0.0132. So step 4, we would say PV is it less than or greater than 0.05? It is less than 0.05. So what are we going to do? We have two options. We reject or we fail to reject. So what are we going to do? Did we find evidence? Is that unusually low? Yes, we will reject the null hypothesis. There is evidence to conclude. I said suggest. I said to suggest, or we can use the word conclude. That the proportion of M&Ms that are blue is less than the 24% they claim. I'm angry. And back in the day, they don't allow this anymore. Statistics students would do this, and if they found evidence, you could mail in your results to the Mars company, and Mars would mail you back a bag of M&Ms. They don't do that anymore. But they used to, because everybody started doing it. Oh, it got me a little bit too much, and then a lot of stats teachers would do this activity, and then they were like, oh, and then they would mail them back a free bag of M&Ms. They don't do it anymore, though. And that's the end of the hypothesis test. That's the entirety of it. So let's go back to so that's the end of the notes. Let's go back into the Desmos here. I'm kind of walking you. I put a little information here about making the decision. A little information about what is the p-value actually doing if you want to get in a little bit more knowledge about it. So going on into the next one. If it's less than alpha being 0.05, it rejects, so more information. And as I said, so this is just, if you want some additional information that goes deeper into what I've said, the slides provided. All right, let's look at slide 11 together. When do we reject and when do we fail to reject? So if we fail to reject, we reject when we find statistically significant evidence. Okay, so that goes right there. And we fail to reject if it's not statistically significant. Does that make sense? So p-value 0.051, and we're using alpha. Is 0.051 less than 0.1? True or false? Is 0.051, the p-value, less than 0.1? Yes, so we would reject. Next one. Is 0.024 less than 0.01? Or no, it is not. So we're going to fail to reject. Is 0.024 less than 0.05? Yeah. It is. So we would reject. Is 0.024 less than 0.10? Yes. So we would reject. Is 0.051 less than 0.05? No, so we would fail to reject. Is 0.11 less than 0.10? No, so we would fail to reject. Now, of course, this one we can use different alpha levels, but in this course, all I have time for you for is using 0.05. But you could see that even with the same alpha level, there are some times when you would reject and sometimes when you would not reject. Hey. Why is it not changing? I don't have time. All right. So a researcher developing scanners to search for hidden weapons at airports had concluded that a new device is significantly better than the current scanner. He made the decision based on an alpha level of 0.05. If he concluded the device is significantly better, did he reject or did he fail to reject? He found significant, statistically significant. Did he reject or did he fail to reject the null hypothesis? He rejected. Okay. Based on the decision from part A, what do you know about the relative p-value? That the p-value is greater than alpha or that the p-value is less than alpha? If we reject, that means the p-value is less than the alpha, which is 0.05 on default. What would the researcher have made the same decision? This is a little bit more of an advanced question. If the decision if it was 0.10, If it's less than 0.05, would it be less than 0.10? Part C. Yes, if it's less than 0.05, then it's going to be less than 0.10. So we would still reject that 10%. But we don't know if it's going to be greater than 1% though. We know the p-value is less than 0.05, but since we don't know the actual value, we know it's still less than 10%. I wanted to delete this. This last one is nothing you're going to be tested on. Don't worry on the last one. I meant to delete that one. All right, and with that, the rest of it is your homework.